Hello everyone, welcome back to Everything Swift. Today we will be tackling Leetcode question 33 titled Search in Rotated Sorted Array. We are given an array of integer and we are supposed to find if the target exists inside one of these numbers inside this array, right? The twist here is that this numbers array has been rotated although it's in ascending order. So for example, the original numbers array is 1, 2, 3, 4, 5. For example, now it has been rotated to become something like 5, 1, 2, 3, 4. So basically 5, all the numbers kind of like just move one by one index. 5 became the 0 index, but everything else get pushed by one index, right? So the question still remains the same. Does the target exist inside this rotated array, right? So that's the task that we have to do. So the quick tip here is that we are told that this array is sorted, right? It's sorted in ascending order, but not in the typical manner because it is rotated. But here's a quick tip that if a question asks that tell us that the array is sorted, right? If we do see a keyword like sorted, right, we should sort of like kind of push our mind towards thinking whether binary search can help us out here, right? That is the tip. This is the keyword to know whether we can apply binary search as our solution. And that is the solution that we're going to use. We are going to utilize binary search to solve this problem. Although there's a twist here, so we have to do extra checking for us to enable the binary search here, right? So let's go ahead and try this out. If arms is empty, I return -1, right? So basically, as stated here, if we don't find the numbers, the target inside the number array, we just return -1, right? So in the world of Leetcode, this probably wouldn't happen. We probably would get an array of integer unless it's stated in the question that we have to handle empty case, but it's kind of like just a habit for a small tiny bit performance here. If it's empty, we just exit as fast as possible. We don't have to perform any operation further down because it's pointless, right? So, yep. Now let's get started to set up our binary search here. I'm going to create a start variable and ending variable here, num.count -1, right? So just typical binary search. We need a start and ending pointer because we are going to find the mid value, and then further on we'll just keep breaking down the options, the candidate that we have to consider basically, right? So while start is less than equals to n, and let's calculate the mid value here, start n minus start divided by 2, right? So I'm using this formula here instead of just only n minus start divided by 2 is just to handle the potential scenario of integer overflow. So basically this is the formula to avoid that. Now let's get the mid value here, nums of mid. So the first thing that we're going to do is if mid val equals to target. If it is, let's just return it, right? Because we already found the target. So this is the ideal scenario. But let's say on the first attempt we don't get it, or any attempt we don't get it. How do we further break it down? So this is the twist, right? That we need to handle. We need to do an extra checking so that we can continue using binary search to break down the candidates for us to sort of like narrow down our options to see if we do find target inside our numbers array. So the first one is, let's check if mid-val is bigger than equals to nums of start, right? So, and then else is, well, if it's not. So the first thing that we're going to do in this if conditional statement here is we should also check is mid value bigger than target, and is target bigger and equals to nums of start. So why is this check important to us? What does it tell us? It tells us where target is inside the array, right? Inside this rotated array. So for example, if mid val is bigger than nums of start, okay, and if mid val is bigger than target and target is bigger than equals to nums of start, we know for sure target is definitely on the left side of the array. It is before mid-val. So what does that tell us? It tells us that we need to update this n variable to become less than mid by minus 1, right? Because we know for sure that it's never going to be on the right side due to this condition here, right? And then the opposite is just the same, right? If it's not, if target so happens to be bigger than mid-val and basically this if condition is violated, right? We know for sure that target is always on the right side. So what do? We need to update this start variable to be bigger than mid index here, right? So start equals to mid plus 1 because we know for sure it's never going to be any value before the mid index, right? So the same thing in the else condition, we will perform the same check, right? If mid-val is less than target and target is less than equals to nums of n. Basically, what does this tell us, right? It tells us that the target is definitely on the left-hand side of the array, right? So we just need to update our array here. Starting pointer is mid plus 1. And then we can just do mid minus 1. So it's exact same thing here, just the check is slightly different, but we're just finding out where the target is inside the array. And then basically that's about it. So I'm just returning -1 here because if the binary search does succeed, we will exit inside this if condition here. If not, we'll return -1 because we failed to find the target inside the rotated array, right? So I know that's a bit of mouthful, but basically the strategy is we are still using binary search. We're just finding out where the target lives inside the array, right? And we do that by using this if conditional check here, uh, as well as this one, just to figure out where exactly is the target inside the array right now, inside this rotated array. Once we find out that, oh, it is smaller than the mid, well, then basically we need to shrink our n variable, and the opposite is like if it's towards the right side of the array, then basically we just update the start pointer to be above the mid because we know for sure it's never going to be on the left side, right? So I hope that's clear with this code. Let's just try and run this and hopefully it works. There we go. Let's try and submit this. And there we have it. That is the solution for this question here. We use binary search to solve this question. And as always, like if you guys find this kind of video helpful, please feel free to subscribe. I'm trying to grow this channel. Thanks so much for your support and take care and bye bye.